Hey 8th graders, today's assignment is going over net force, so this really goes into our last 1.3 force and motion assignment that we did for Amplify your learning targets. I can calculate net force and use this information to determine the change in movement, if any, of an object, and I can identify balanced and unbalanced forces. So first out, you guys have your warm-up to complete on slides 2, 3, and 4, so make sure you guys use your draw tool to circle which change of movement you guys would see if a force is applied to an object. But let's focus in on what net force is today. So net force is basically the overall push or pull in an object. So when we're talking about everyday objects, we often see multiple forces acting on those objects. So when we add up all those forces or subtract forces in different directions, we can calculate our net force. Remember that an object does not have force, but a force can be exerted on an object. So I don't have force, but maybe someone's pushing me and exerting a force on me, okay? And that would cause the object to change or move its velocity. Okay, for your next activity, you guys are going to right-click and watch this little video right here on balanced and unbalanced forces. Okay, it looks a little something like this. If there, oh, it looks like there's an ad for you guys. So watch that video, and then you guys will move on, and we're going to take a look at what a balanced force is based on what you guys saw in the video. So if we are looking at a balanced force, we're going to be calculating a net force of 0 newtons. So that means we're not going to see any change in the object's motion. Okay, so if the object was at rest, we're not going to see a change in that. That object is going to stay at rest. Okay, if an object is moving along at a constant speed or a constant velocity in a certain direction, again, that balanced force is not going to change that object's velocity or motion, so that object is going to stay moving at the same velocity and in the same direction. On the other hand, unbalanced forces, you're going to see a net force that is not equal to 0 newtons. Okay, you're going to see some value for that net force. We are going to see a change in the object's motion. We might see a change in direction, speeding up, slowing down, stopping. Those kinds of things would all be an unbalanced force. So if an object was at rest, it will start to move. But if an object was moving, it could either speed up, slow down, stop, or change directions. So let's take a look at some examples. So right here we have a little tug of war for this cart of toys. You guys can see the left and the right forces are equal. So that cart of toys is not moving. That is an example of a balanced force. Okay, however, we've got this right guy pulling a lot harder on that cart of toys. So he's pulling a lot harder. It looks like candy maybe. And so that object is actually going to start speeding up and moving towards him. The more he applies that force, the faster that cart's going to go towards him. Okay. Here is another example of force. So we have some books sitting on a table. We have force from the weight of those books being pulled down by gravity. And we also have a normal force that the table exerts on the books. Okay, with that being said, this is an example of a balanced force. Okay, those books are not moving. Okay, but what would happen if I stacked so many books on that table that it broke? Is that a balanced or an unbalanced force? Okay, basically our force from gravity would become too high, and the normal force from the books would not be high enough. The table would break, those books would fall, which would be a movement that we would see for an unbalanced force. Okay, we've got little Susie here cruising along down the street at 100 miles an hour. The force of her push is equal to the force of her wind resistance and her friction from being out on the sidewalk and out in the environment. So those two arrows are equal, so this would be an example of a balanced force. Susie's going to keep moving at 100 miles per hour as long as those forces do not change. However, if she kicks a little bit harder, we're going to see that this is now unbalanced and she's going to speed up. Okay, on the opposite hand, if a big old gust of wind picks up and our wind resistance becomes greater, okay, then she's going to slow down because her force of her push is not enough to overcome that, and she's going to see a change in motion. Okay, here's some keys for you guys as you calculate these net force problems. So if you guys see forces or arrows in the same direction, you're going to add those forces together first. Okay, if you guys have any opposite arrows, then you're going to subtract those second. Okay, so if they move in opposite directions or they point in different ways, subtract those forces. Okay, your net force is going to include a direction that points to the greater force, so right, left, arrow, whatever the case is. Okay, so here's some examples for you guys, and I'm going to use the draw tool to fill these out. So here we got a box. We have 10 newtons to the left, 10 newtons to right. This is an example of balanced. Your net force would be 0 because it is balanced, and we label that newtons. And our movement would be none. So we would see a constant velocity, meaning that it was stopped, it's going to stay constant or stay stopped. Okay, in this direction we got 5 to the right, 3 to the left. So because these are moving in opposite directions, we're going to subtract them, 5 minus 3. So that's going to give us a net force of 2 newtons. Our larger force is to the right. Okay, and this is going to be an example of an unbalanced force. Okay, our movement is going to be to the right. Okay, so we might see it increase to the right. I guess it really depends on the movement. Basically, we're going to see a change in the velocity. Okay, this one we've got 3 to the left, 4 to the right. So this is your larger one. They're in opposite directions, so we're going to subtract them. So 4 minus 3, your net force is going to be 1 Newton, and we're going to take that to the right. It's unbalanced. And our movement is again going to be a changing velocity. Okay, we're going to see it increase in speed or change direction or depending on what it was doing before. So we'll just consider it a changing velocity. Okay, and then this last one here, we've got 2 both to the right. So because they're in the same direction, we're going to add them together. So 10 plus 10. So our net force is going to be 20 newtons, again to the right. This is unbalanced. And our movement, again, is going to be a changing velocity. Depending on what it was doing before, oops, that says changing. Wow, that's beautiful. Depending on what it was doing before, it's kind of going to dictate the move. So we'll just say it's a changing velocity. All right, moving on to your homework for today. You guys have this link on slide 17. You guys will right-click that and open the link up, and it's going to take you into this Microsoft form. 2 parts to this. The first part has 30 questions, all multiple choice, so you guys should get some immediate feedback as far as a grade on this assignment. Each 3 sets of questions, you guys will see the same picture. So first one, you'll calculate net force. Okay. The second one, you'd tell me if it's balanced or unbalanced. And the third one, you're going to tell me constant or changing velocity. I just want to touch on that really quick. A constant velocity means it's going to stay doing what it's doing. So if it's stopped, it's going to stay stopped. Okay, those forces aren't going to change its motion. Okay, if it was moving at 10 miles per hour, it's going to stay moving at 10 miles per hour. Because it's a balanced force, those forces aren't going to change its motion. However, if it's unbalanced, which is going to be the case of most of these that you guys see, we're going to see some change in a velocity. So either that object might speed up, it might slow down, it might stop, it might change directions, whatever the case. So that's our difference kind of between constant velocity, doesn't change its movement, and changing velocity, we'd see those 5 things that we saw in changes of movement from the other day. Okay, I'm going to go through. There's 30 questions on here. The second part of this, I'm not going to show you guys. You can figure it out. There's 3 word problems where you guys kind of just need to, on a piece of scratch paper, draw a picture, draw your arrows to show the force. Again, they're multiple choice, so you guys should have some immediate feedback. So go ahead, finish up your 30 here, hit next, go do those 3 word problems. They're again multiple choice on the next part of this, and then go ahead and hand this in. I hope you guys are having a great day, and I'll talk to you soon. Bye.